Welcome to Investigation 1.2. In a spin, we are going to be looking at rotations. Specifically, here's our focus question. What does it mean to say, that's what it should say, that a figure has turn or rotational symmetry? How is each point related to its image under transformation by rotation? So we're going to be looking at the relationships between points and seeing if there's any sort of similarities or patterns that we can see when we rotate a figure about a given point. So, a couple words worth knowing. Very first one is rotational symmetry, which means that a figure can be turned about a point. A figure can be turned less than 360 degrees and look the same as the original. So looking at, say, a heart, we can look at a heart and say we'd have to rotate it all the way around 360 degrees for the heart to look the same. However, if we had a diamond, it's a possibility that we could rotate it just 90 degrees and have it look the same, or 90 degrees again, or another 90, or another 90. It could potentially have 4 rotational symmetries within it to make it look exactly the same. A rotation itself is a transformation that turns a figure counterclockwise. Now, one thing that you'll come in that will be a little bit frustrating if you end up using that same app that I was talking about, transformations, through the CMP dashboard website, you will end up finding that the only way you can rotate things is clockwise, so turning as a clock turns, spinning to the right and around. However, conventionally, so this is how it's always been done, that's what it means by conventionally in this case, it's always been done that whenever you rotate something, you rotate it counterclockwise. So you're turning it to the left. And that is because if we look at our coordinate grid, when we're looking at that sort of thing, we are looking at quadrants, and we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And counterclockwise means we're going from our first quadrant to our fourth quadrant and going through 1 and 2, or 1, 2, 3, 4 in that way. If we rotate something clockwise, we're going against the grain and we're saying 1 to 4, then 3, then 2, then back to 1. And that's not like fitting with our brain and how things are thought about. So our rotation has to be counterclockwise. So it's going to feel weird, but if you do it on the website, you have to do it clockwise. So you're going to have to go to your first rotation and have it be twice as much as you initially understand. I'll show you in a moment when I actually do it. A center of rotation is the point about which an image turns. So if we had the letter T and we needed to rotate around a certain point, 180 degrees, we could rotate it. Actually, I should make my T on the other side so it's easier to rotate my T, and we need to rotate it 180 degrees. We'd end up with our T being upside down on the other side, but it's turning around this point. It's a possibility that you end up having maybe that letter T and its center of rotation is on the tip of it. So if we were to rotate that T around, our image would be coming off of that point, and we'd have a rotation 180 degrees in the other direction, and our T's would be almost connected. So center of rotation can be in many different places. You have to kind of figure out where that location is. As well, we also have an angle of rotation, and that tells you exactly how much you need to turn. So in this case, you'll be using your angle rulers, and that angle tells you how much to rotate something. So you'll see angles of rotation of maybe 45 degrees. So 45 degrees is, if we are thinking about a 90-degree angle, it's half of that. So you might see a rotation of a little bit. You could see angles of rotation of 30 degrees, so even smaller. Or you could have big angles of rotation of, say, 180 degrees. If we think about the letter S, it has a center of rotation about its middle of its S. And if we were to rotate it 180 degrees, we'd have the exact same image. It would still be an S. And so it has a 180-degree rotation. It could also turn back the other way and be back upright and be 180 degrees. So thinking about the angle of rotation, you might do something a lot or a little depending on what's going on. So we're going to start out this investigation with an image. Image is a gigantic X. X marks its spot. And with this, I want you to try to figure out what is the smallest clockwise rotation in degrees that will rotate the X to a new position in which it looks unchanged. And I say clockwise, even though I've been saying counterclockwise, only because that's the way the program is working for me when I was doing these images. I had to rotate it unconventionally. I had to rotate it against the grain. Ideally, it would say counterclockwise, and I'd be paying attention to perhaps this point L and seeing when it could potentially meet up with a point that's perfect as it rotates around this point M. So we're thinking, what is the smallest rotation I could make with this? If I were thinking about it, I could potentially move my L point in comparison to the M. So if I were to look at this, I'm going over 2, up 2. And say if I were to just move it over, or move it around 90 degrees, where would it be located? So I would have to think about that, and I would have to think, okay, over 2, up 2, maybe my L is pointed right there. And if that's the case, my K would be here, my J here, and so on. And so I'm seeing that my image is not quite in the same place as the actual image that I want it to be. It would end up looking something like this. So we're going to look at the next image that I've created. So we have our original right here. So here's our X. And if I were to rotate it just 45 degrees, so 45 degrees counterclockwise, I've moved my point L to here. It's rotated 90 degrees, but it hasn't gone right back on top. We want it to look like this X. We don't want it to look like a sideways version of that X. We don't want it to be totally different. Okay, there's our image of our original. Oops, I should be more accurate. And it's not quite what I want it to be, so I don't want that side. Okay, so our original is in green and our image is in red, and our image does not fit our original. It's not 100%. So 90 degrees was not enough. However, if we rotated it a full 180 degrees, you can see that by this mark right here. If we rotated the L a full 180 degrees till it was here, so we can barely see that L prime, we can see that the image is now on top of it, on top of the original. So here's the original, and we can also see that the image is now fitting perfectly on top of that. So that's kind of cool. How many more rotations is needed to make it fit on top of it again? Here's another 90 degrees, so we're now at 270 degree rotation, but it's not quite enough. We need it to be even more, a full 360 degrees around to make it work. So this particular X, this X has a rotational symmetry at 180 degrees and at 360 degrees. Nothing else has, or it doesn't have any other rotations in between that. However, we also can see, because we were just talking about line reflections, we can also say that this X probably has some line reflection as well. And looking at that, we need to see if we can flip our X without changing its appearance, and if so, what is its line of symmetry? So here's that original X again. Like outlining it, it's kind of fun. Here's our original X, and if we were to look at this, we could say, well, I see a line of symmetry right here going through its horizontal axis, like right down the middle, because then I could make L turn into the H, the K would turn into an I, the B would become an F, the E would become, or the C would become an E. So we could say, this is sort of the notation that you're going to say, when you're talking about even the reflection of the star that you have in your image in your book. You'll say L becomes H, K becomes I, and you're seeing that they are corresponding to those particular points on its reflection. As well, this big X also has a vertical line of symmetry right through it. We can see it right there. And we could also say that in this situation, F would become H, this point becomes this point, E becomes I, and we could do that for every single point on our X. Now, we also need to understand how to show some rotational symmetry within an object, and you need to understand that it's not just one rotation. You want to see how many rotations you can get with this sort of thing. So here's a flag, and we need to use it to make a design that has rotational symmetry with an angle of rotation of 120 degrees. That means if I were looking at something that has a 360 degree, like if we had to go around 360 degrees to get it to look like itself again, we need to make it look like itself also at 120 degrees and at 240 degrees. So we can see that there's going to be 3 total rotations or 3 total images that we will see. And the reason why I know that is I am taking 360 degrees, I'm dividing it by the number of rotations or the degree rotation we need to make. So here's our flag, here's our initial flag, and I have decided that we are going to rotate it about this point right here. So partway down the staff of that flag. And if we were to do that, we could rotate it just a little bit and see that our flag can be rotated to here. Oops, I chose a different flag. Sorry. Oh well. So here is a 120 degree rotation. Now, is this finished? No, because if I were to leave it just like this and I were to say that it has rotational symmetry at 120 degrees, we wouldn't be able to pick up this whole image and rotate it 120 degrees and actually have it be the same, because this flag right here would not have an image to go onto right here. Okay, there wouldn't be enough. So we would also need to do one more rotation of 120 degrees, because we'll have 3 total rotations, we'll have 3 total images that we're looking at, and this would be our final product. This is our product where I have my original flag. Here is my first rotated image. Oops, I'll do that in a different color. Here's my first rotated image of that flag, and then here's the last one. So we have 3 total images, and this now has a rotational symmetry at 120 degrees, because it takes me 120 degrees to get there. It takes me 120 degrees to get here. And lastly, it takes me another 120 degrees to get here. So that's kind of fun. Now, we're also going to look at a fishy design. So we have a fish, and we need to make it have a rotational symmetry of 90 degrees for the angle of rotation. And this time, I'm going to rotate it about this point at its bottom jawbone, and we're going to see it rotate just 2 units essentially around that point. So my image, so if I were to look at this particular like hinge of its jaw, you will find it right here, you'll eventually find it right here, and you'll find it right here, that the image of its jaw will eventually be in all those places. So let's do just that. Here's the first rotation that we have, that as you can see, that jaw has rotated 90 degrees. So every single one of these points, if I were to look at this point, it has also rotated that 90 degrees. As you can see further out, it does travel in a bigger path because it's traveling on its own sort of circumference of a circle. However, it's only rotating 90 degrees. We can also see for our next one, we now have the jaw of our fish in 3 of the locations around its rotational center of rotation. We can see that it's rotated 90 degrees 1 time and 90 degrees 2 times. So we have both of those 90 degrees. However, this image still isn't finished. We need to show that it has 90-degree rotational symmetry, so we are going to have a total of 4 images. I know that because we'll have 360. We're dividing that by 90, so looking at those degrees, and we'll have 4 rotations, because 90 goes into 364 times. Very last one is our final image, and we can see here our fish, original fish, in its jaw bones where it has hinged, has now rotated 90 degrees 4 times. So playing around with this concept, you are going to be using your angle ruler, and you are going to be precise. You are going to be attending to precision to be working through this particular investigation. It's very important that you try to attend to precision, because if you don't, you will end up with a funky, fishy mess. Maybe not really, actually. You guys are just rotating flags. However, I was rotating fishes, and that's kind of fun. So I'm going back to the beginning, and what I'd like you to work on is investigation 1.2, and you're doing A through C of this investigation. I hope this found you in a happy state, and I will see you later.